In the Marvel movie Thor Ragnarok, Thor, a Germanic god and the main character, must stop his older sister Hela from causing Ragnarok to Asgard, or the ultimate destruction of the planet.
I need to stop her here and now.
To prevent Ragnarok, the end of everything.
After their father Odin died, Thor and Loki were chased off to the planet of the Klar. In this scene, Thor has to team up with his mischievous brother Loki to defeat the guards of planet Klar. Their overall goal is to defeat anyone who impedes their return to Asgard.
Maybe they're still good in you, but let's be honest, our paths diverged a long time ago.
Yeah. It's probably for the best that we never see each other again.
That's what you always wanted. Hey, let's do get help.
What?
Get help.
No.
Come on, you love it.
I hate it.
It's great. It works every time.
It's humiliating.
Do you have a better plan?
No.
We're doing it.
We are not doing Get Help.
Get help! Please! My brother's dying! Get help! Help him!
Oh, classic.
Still hate it? It's humiliating.
No, not for me, it's not.
Whoa. Did you see that launch? Did you see that human projectile being hurled at the guards and knock them down like a group of meek bowling pins? Let's dive into the physics behind that throw.
Get help! Please! My brother's dying! Get help! Help him! My head!
Using the clip and information supplied by the Marvel Universe and the actors themselves, we are able to gather some raw data. We learned that Loki spent about 1.16 seconds in the air. His height and weight, which is taken from his actor Tom Hiddleston, is 1.875 meters and 79 kilograms. We can see that Loki made about 2 rotations in the air before hitting the 4 guards. By using his height as a reference, we can infer that Thor threw him about 3 to 4 meters, which we'll round to 3.5 meters. When comparing Loki to the guards through observation, we infer that most of them are shorter than Loki, which gets us to 5'10" or 1.778 meters. We are also assuming that the guards have a build similar to typical FBI agents, who are fairly well built and have a decent amount of muscles. We also estimate that they have an average weight of 72.57 kilograms, still less heavy than Loki.
From the clip, we can see that Thor threw Loki in a projectile manner, causing Loki to make 2 rotations in the air before hitting the 4 guards. The collision is inelastic since there is no repelling force. Loki and the guards all traveled in the same direction. We can split the energy from Thor's throw into 2 components: energy from projectile motion and rotational kinetic energy. Energy from projectile motion can be calculated with the equation E equals 1/2 times IW squared. Although Loki was rotating in a weird fashion, let's assume he's in the same shape of a cylinder. We can then find his moment of inertia with the equation of I equals 1/2 mr squared. Tom Hiddleston has a waist measurement of 84 centimeters. Using the equation C equals pi r squared, we calculated his radius to 1.57 centimeters. From the equation RW equals V, we got the angular velocity of 1.92 radians per second. By plugging all numbers in, we get a rotational kinetic energy of 179.46 joules.
The other part of the equation calculates the total energy during the projectile motion. This energy can be split into 2 parts, potential energy and translational kinetic energy, which will then be added together. In the clip, we see Thor throwing Loki from a height that's around his waist, which can be said is half his height. The height of Thor's actor, Chris Hemsworth, is 1.9 meters, so we can conclude that he threw Loki from 0.8 meters above ground. Potential energy can be calculated through the equation energy equals mass of Loki times gravity times height of Thor at his waist. This will total us to 79 times 9.8 times 0.8 equals 619.36 joules. As Loki is thrown, he reaches a maximum height, then falls due to gravity and hits the guards. From that, we can conclude that there is a y component and an x component of the velocity. The x component of the velocity is 3.02 meters per second, found from observation. The y component of the velocity can be calculated through the equation gravity times the time it took to reach maximum height, which will get us 5.684 meters per second. Together, the x and y components of the velocity will result in the magnitude of the velocity to be 6.44 meters per second. Translational kinetic energy can be represented in an equation energy equals 1/2 times mass times velocity to the second power. By plugging the values in, we can get a value of 1638.21 joules. By adding the rotational and projectile energy together, we will get a total energy of 2257.57 joules.
The last of the physics lies in the collision of Loki and the four guards. As Loki collided, the guards fell on their backs and slid while Loki rolled off. Through observation, we estimate the distance traveled to be about 0.5 meters. The equation for inelastic collision can be represented by m1v1 plus m2v2 equals m parentheses 1 plus 2 close parentheses vf. Loki's velocity just before contacting the guard is 6.44 meters per second. Since the guards are pretty much just standing still when they were hit, we'll say that their velocity is 0. Since all guards were hit by Loki, we'll count the 4 guards as one giant mass. We have previously predicted their average masses to be 72.57 kilograms, so 4 of them in total will be 290.28 kilograms. However, since they are also wearing some form of protective armory, let's increase their total mass to 300 kilograms. 79 kilograms times 6.44 meters per second plus 300 kilograms times 0 meters per second equals 79 plus 300 times Vf, gives us a final velocity of 1.34 meters per second. The guards were moving for less than a second before they were struck down and slid.
In conclusion, this scene proves just how powerful Thor is. It takes a great amount of force to propel Loki at that speed and distance.